Hey everybody, and welcome to SpaceWeek Live for Sunday, August 9th, 2020, the year to end all years. So here we are at the end of another week. A little quieter than the previous 2 weeks, but still pretty eventful. We had a couple big things happen. First of all, let me see if there's anything in the chat waiting for me. Oh, microsound. You mentioned that... What did you say? Oh, yes, you predicted that I would be shaved and something. Shaved and with the SpaceX hat. The SpaceX hat is a good bet because currently that is the only space-related hat I have. I would have more probably with my own logo on it, but Teespring doesn't sell hats for some strange reason, despite the fact that hats are sort of a staple of the merch world. I do have my kofefe. It's a little bit cold. Well, lukewarm / tepid. So let's go ahead and get started. First of all, welcome to you all. I will even type that in the chat. Welcome to you all. See, I say what I am typing as I type it, so that when you see it, you'll know what I typed. Okay, so Space Week. Last week, now we already covered this in last week's Space Week episode, but last week on Sunday, very cool, very big event. Astronauts Bob Behnken and Doug Hurley successfully deorbited in their Crew Dragon craft and splashed down in the Gulf of Mexico, about 100 miles from Pensacola, Florida. So here, actually, you know what? Let me switcheroo to the browser. Here we go. Just a brief view of that.
We should be able to see the Gulf of Mexico here in the shot just momentarily, as we're now just about 20 meters off the ocean.
Splashdown.
As you can see on your screen, we have visual confirmation for splashdown.
Kersploosh. And so they brought the Crew Dragon craft over. Well, well, first of all, okay. So something that happened here. I'll just let that run. So something that happened that was not ideal was that a bunch of civilian boats showed up, including one with a political flag driving right past the cameras. A bunch of civilian boats showed up because they knew approximately where the Crew Dragon was going to splash down, and they wanted a piece of the action. Now, they did not appear to get in the way, but the incident raises a lot of concerns, and I don't know what sort of official conversations have been had about this, but I mean, these missions are, you know, they're not playthings. They're not. We're not messing around. I mean, these are serious missions that cost huge amounts of money. Lives are at stake. With regards to the safety of the craft needs to have a clear descent path. There needs to be nothing in the way. You know, if it were to land on a boat, it would smash it. The hypergolic fuels that are used in the Draco and Super Draco thrusters can create you know, particles surrounding the craft that need to dissipate before any humans breathe that air, or it will be poisonous to them. And that's why the extraction of the crew took so long after they plopped the Crew Dragon down on the deck of the Go Searcher or Go Navigator ship. I forget which one that was, but because they had to wait for the hypergolic toxins to dissipate. And, there are a lot of dangers involved around the spacecraft, which is why it's very important that the area be completely clear of civilian craft. Even such stupid things as a civilian craft getting in the way of the recovery ship as it's trying to maneuver. So I am hoping that in the future, these manned missions will have some some Coast Guard support to keep the civies away from there, because it's not a, they're not part of the mission. They're not trained. They don't know. Basically, they're a risk to themselves and to the astronauts and to the craft. So yeah, that was, it was amusing to watch, but it was not good, and I hope that they take steps to ensure that civilian craft are kept far away from the landing zone in the future. Now, let's see. So, yeah, so it was over an hour before they... Oh, hey, that's me. It was over an hour before they finally extracted the crew. But they got out fine, and none the worse for wear. Probably a much more pleasant landing than the Soyuz module, which not only is very cramped, whereas Crew Dragon is quite roomy, but lands hard on the Kazakh steppes, as opposed to, that's STEPPES, as opposed to soft water landing. Oh yes, I was going to mention this was the first human astronaut water landing in what, 45 years, something like, since the early 70s in any case. So yeah, pretty cool. All right, let's check for questions on this topic. Yeah, Snow Kittens, I am not shaved today. It was a few days ago. I considered it, but I was like, why? Hashtag Osama is asking, place a photo of Starlink satellite. Now this is translated from Portuguese, and I do not know proper Portuguese pronunciation. I'm familiar with Spanish, but not Portuguese. Place a photo of Starlink satellite. I look on the internet, but I've never seen their real format. Okay, so I'll just type a message to him. There you go. All right, to the Portuguese, Brazilian. All right. Maria Kutujan is asking, if it is not possible to land at the given location, is there another place prepared for landing? Yes. So they have multiple. They have multiple potential landing zones, and they can adjust that as necessary. I think they even have some control over where they land after the deorbit burn. Maybe not, because once they do that burn, once they're in the atmosphere, they're in the control of gravity, drag, and and that's about it. I don't actually think they have maneuverability when they're in the descent phase. But I do appreciate the folks that are saying slap the like button. It seems, well, that's how YouTube knows that people are interested in the content. So if you like this sort of thing, if you like these episodes and the casual banter, then hitting the like button does tell YouTube that people are interested, and therefore the algorithm, the big capital A algorithm, will place my videos and streams more prominently, and they'll put them in front, put the thumbnails in front of more people's eyes, which will help not only the channel but also you guys, because the more the merrier. The more viewers we get, the better content we can do here. Mark Desire says he thinks I need to update the calendar. Okay, we'll get to that shortly. Alright, Astronomy Films didn't get the notification for this. I did set it up before, I think the notification is 30 minutes prior, isn't it? I did set it up before that, like an hour and a half or 2 hours before that. Okay, so moving on. On Tuesday, SpaceX's, this is the biggie. On Tuesday, SpaceX's Starship SN5 prototype test article successfully completed its 150-meter hop. This had been highly anticipated for a long time. They had a series of pressure test failures, and then intentional tests to failure, but also some not intentional RUD-type rapid unscheduled disassembly failures of the while doing pressure tests earlier this year. But they finally got SN5 off the ground. Let's take a look at that. So that was awesome. So let me see here if we get a yes. Okay, so let's track back here to the beginning. So you see on the right we have Starship SN5. That is 165 feet tall, and I can't do the conversion in my head on the fly, so 165 feet, it's however many meters. And then on the left we have Starhopper, which is the test craft that did its hop last year, back in whatever it was, October. Now Starhopper is what, 70 feet high? Here, let me hold on. Starship, Starhopper. I just want to make sure I get it right. 128 feet tall, no. Alright, whatever. Too much information. So anyway, Starhopper is almost two-thirds shorter than SN5. SN5 was quite a tall boy, the height of a 16-story building. Now you may, okay, so now if we look at it at the end, you can get a better view of it. So this view is from Lab Padre. The initial video was from SpaceX. This view is from Lab Padre because, amusingly, SpaceX's video, even the video on YouTube, was exactly 1 minute long. So they sort of cut it off short here after the landing. If we look, there it is, boom. And they cut off the video because Twitter Was it because of Twitter? I think it was because of a Twitter limitation on video size. In any case, this view here is from Lab Padre. I could be getting Twitter confused with Imager, which I use a lot. So apologies if I get that confused. I'm old, so. So you see there at the top of Starship SN5, I'll just call it SN5. There's a block. You can't see my cursor, but I'm pointing at. I can't even reach over there. It's way too far. There's a looks like a box on top. So according to the Lab Padre commentators, excellent commentators, by the way. And by the way, you should go visit their channel at your first opportunity after this live stream and go sub to Lab Padre. According to their commentators, that box is actually it includes a mass simulator because the rocket has no nose cone or payload, so there's actually apparently a weight up there that helps to balance the rocket out. Now, as it flew, notice that, let's take a look again. So it raised up to about 150 meters high, which is, well, actually, you know, that thing looks like it went higher than 150 meters to me. Because 150 meters isn't much more than 3 times SN5's own height. But you can see, as it's maneuvering itself around, there's the engine, the one Raptor engine. By the way, this whole craft, I mean this whole 165-foot tall grain silo, basically, was thrust up into the air by a single Raptor engine, not even at full throttle. Raptor is a monster. And what are there supposed to be, like 30 Raptor engines on the Super Heavy? My goodness. So, but not only just the Raptor, but also you can see a little puff from one of the RCS thrusters, the reaction control system thrusters. Poof. Those are the thrusters that are used to help, orient the rocket. I'm not sure if RCS thrusters are often used in atmosphere. I mean, I know they're definitely used up in space to reorient the rocket where it needs to be pointed, but I don't actually know if they're used in the atmosphere very, very much, except for things like this test. But then, you know what? Let me slow this down to 0.5. So we see here. Okay. So we see here. This is the view from inside the skirt, which is because the outer shell of SN5 extends down below the level of the engine, which is different than most of the rockets we're used to, which have the engine sticking out from underneath the rocket. SN5 has this skirt that extends down below the level of the engine, and then the landing legs. There are 6 landing legs, hydraulically activated, and they watch them pop out. This is cool. Boop. And all 6 landing legs pop out, short little stubby legs. There's some sort of fire on the engine, which is apparently due to, there may be official word on it now, but it's apparently due to some sort of methane leak, in some of the engine's tubing, piping. Hopefully the rocket engine can handle a little fire without being damaged, but different parts are intended for different levels of abuse. So that'll be for SpaceX to analyze and mitigate so that they don't get unintended engine fires where there's not supposed to be flame. And then it comes down nice and gentle, because SpaceX really knows how to land their rockets propulsively. They've gotten really good at it. Now, when it did finally come to rest, it looked a little askew. Now, I'm tilting my head to the side here. What I should do is, if I wanted to take the time to do it, I could, like, screenshot this and then share Photoshop or something to write the view and see if this is... It looks a little askew, but the camera itself was also tilted to the side a little bit because it's mounted on a... so this is Lab Padre's lab cam, and it's mounted on a pole of some sort, I guess, about 0.7 miles, 1.1 kilometers from the launch pad. And I'm not sure about the distance from the landing pad, but the landing pad's not that far away. So, in any case, it's mounted on a pole, so apparently it's not completely level. So, let me take a look at the chat and see what I'm missing, because I do see some stuff scrolling by. Mark Desire says he can't really say that Starship looks like a starship. No, not at the moment. Now, at the moment, it looks like a grain silo. It really does. But once it's got a nose on it, and once it's on top of a really freaking huge BFR Super Heavy, it will look very much more like a rocket. Really, the defining feature of a rocket is that it is tall, skinny-ish, proportionally, and has a nose cone. Without a nose cone, it just looks like a cylinder. Astronomy Films asks if I noticed the explosion right at liftoff. So here, let's take a look at the liftoff in slow-mo. Now there was, I don't know if it was an explosion at liftoff or just the blast from the rocket tearing some stuff up on the near the launch pad. I'm not sure what it was, but there was definitely some debris that flew up from the launch pad, and I'm not sure how good a view of it we get in this video. I definitely saw it in some of the others, though, in Everyday Astronaut's video and Lab Padre's lab cam view of the launch. So watch when it... Right, okay, so... Actually, oh, there we go. Boom, debris flying up from the launch pad. That's one violent launch. Oh my gosh. Yeah. So if that was an explosion and not just the exhaust blowing things around that weren't properly secured or something, you know, I'm sure SpaceX will deal with that. All right. Now, one of these days, I swear, I will have a helper, whether it's a moderator or a volunteer, summarize the questions for me. I do have a request for you. If you have a question for me, please tag me in the comments so that it stands out. Please, everybody, don't tag me unless you actually have a question. That way I don't have to read every message in the chat to see if there are any questions. Get Real asked what's the total height in feet. That would be 165. And the box at the top is, I believe, supposed to simulate the weight of a payload, or at least the weight of the nose cone to provide balance to the rocket. Oop. And the chat jumped. Okay. Sorry for the delay. Mad Matt says the legs had a crush softening ability. I heard something about that. So if we look at the legs, so if you look, so right now the legs are upside down. They're in the process of deploying, or they're just prior to deploying. Let's see if I can track forward here. Okay, so you see, let's look at the leg on the far left. So you see the plate, which is the business end. That's what actually lands on the ground. And then just above the plate is a few inches of leg, and then some sort of ring. I think there is some crushing material in there that softens the landing. Remember, this is just the SN5 prototype. They have a lot of work to go before they get to the final product, and so you know, their ultimate goal of full reusability, you know, is not realized at this point. They have additional changes to make to the craft. This was only designed for the purpose of testing, and I believe that includes these crushable leg bits, kind of like they used on the moon landers. They had crush, what do they call it, crush core, that actually crumples to cushion the impact. Cows with guns. Okay, we got some strange stuff in the chat. Ian Pedlar says, if you can find a clear shot of it after it landed, you will see some of the legs are more compressed. And that makes sense, because it does look like those legs are compressible. Okay. Get Real asks, why would they not use some kind of hydraulic shock absorbers in those legs? Probably because, sorry, I'm laughing at the cows with guns. Cow gun. There. Probably because those are complicated and expensive, hydraulic shock absorbers. And this is just a test article. I'm sure that in the final, yeah, these legs are very simple. I'm sure that in the final design, because, you know, I mean, SpaceX, they don't, their development process is no frills. I mean, literally, this looks like a grain silo flying, you know, flying around. Their development process is rapid. What do they call it? Rapid something rather. I'm not big on buzzwords, but they're not going to implement some fancy, expensive and complex landing system for a test article that's only going to be used once, perhaps. I don't think this one is planned to be used again. Or maybe they'll refurbish this one and use it, like expand on it for the next SN6 or whatever. I'm not sure. Iteration. But yeah. So there we go. Successful hop at long last. Now the question that nobody asked, that someone probably should have, is when are they going to take the next step? When will the next flight be? And I do not know, but of course timelines are highly variable based on the results of their testing. You know, if something goes wrong, that delays it. If things go right, then things move more quickly. But presumably the next hop will be the 20-kilometer hop that they've been talking about for a very long time now. I believe that may be slated for SN8, perhaps. But again, only time will tell. And they're obviously making progress. They're working hard, and so let's cross our fingers and wish them the best of fortune in this development process, because Starship is the future. I mean, if they can pull this off, if they can get this craft built and operate it reliably and reusably and safely, then, I mean, total game changer. Amazing opportunity for the future. Let's see. I do have a couple questions here. Only one unit asks, was that flame outburst or exposure normal? I think he means the, well, if you're referring to the flames on the engine, which we see in this freeze frame here, I don't think that was intended. I think that was some sort of a leak, you know, from, I mean, the Raptor is an incredibly complex engine. If you've seen a picture of other rocket engines next to a Raptor, the Raptor looks like rocket science compared to the other rocket engines. It is an incredibly complex engineering marvel, and so complex means more points of failure, or more points at which something can go not as planned. Let's put it diplomatically. So, Niklas Juel Jacobson. I'm sorry. I'm trying, but not not knowing where you're from exactly. Maybe a little off on the pronunciation, but Starhopper was the first prototype for the Starhopper is the same, approximately the same diameter as SN5. It's just a lot shorter, and so first they had a short test ship. Now they have a tall test ship, and next, once they get to that point, they'll have an even taller one with a nose cone, and it'll go up 20 kilometers, hopefully. But the next test article should look more like an actual spaceship. Snow Kittens is saying this cost tons of money to disassemble the completed N1s and end the lines, way more than launching more N1s. Oh, he's talking about the Soviet moon, the Soviet N1 rocket, and the space race. I must have missed that part of the conversation. So, only one unit asks, because they are so complex, do they cost so much because of that? Yeah, complexity costs money. Complexity is more difficult to a complex system is more difficult to manufacture than a simple system, and therefore it costs more money because it requires more people, more precise equipment, more parts, etc., etc. Okay, so moving on. From SpaceX, we have accomplished 2 bullet points of today's Space Week. All right. Then on Thursday, China launched a Long March 2D rocket with the Gaofen 904 Earth observation satellite. This was the 50th launch of a Long March 4D and the 342nd launch in the Long March family of rockets. Now, that's not necessarily saying much, because that's kind of like saying, Ford's F-Series is the most popular truck. Well, like every Ford truck is an F-Series, so, whatever. Pretty much, most Chinese rockets are Long March something or other. So, however, they are very prolific in the space sphere, and they do conduct a lot of launches. So, anyway, this particular launch, the Gaofen 904, was China's declared purpose for this satellite was, predictably, land surveys, city and road planning, crop yield analysis, disaster mitigation, and response. being an Earth observation satellite. So let's take a look at that launch. Long March 4B, not the biggest rocket, but gets the job done, and yay for China. Speaking of disaster response, by the way, and this is a serious topic, disaster mitigation and analysis are one of the important uses for imaging satellites. After the devastating August 4th explosion in Beirut, Lebanon, which we all saw, which was caused by a fireworks depot fire that spread to a huge stockpile of ammonium nitrate, despite what the conspiracy theorists might claim. Imagery such as this from a European Pleiades satellite can help search and rescue efforts, determination of exactly what happened, analysis of the blast effects, insight into how to prevent such calamities in the future, the first step of which would be not to store 2,750 tons of freaking ammonium nitrate in the middle of a populated area, or at least mitigate the effects of a potential disaster if it does happen. In any case, so floods and fires and explosions like this, or the one in Tianjin, China in 2015, satellites come in very handy after any kind of disaster, because you get a god's eye view or a very high-flying bird's eye view of the site, and you can do all sorts of analyses on it. Moving on to a happier topic, on Friday, local time, SpaceX finally launched their Starlink 9 mission with 57 more Starlink satellites and 2 Earth observation smallsats from Seattle-based Black Sky Global. Now, this makes a total of about 5 million Starlink satellites currently in orbit. I don't recall the latest number. Not all of the launches have had 60 satellites. Obviously, this one had 57. And there have been at least a couple few that have deorbited since they were launched, either for testing or because they're of some sort of anomaly. So I'm not sure what the actual number of Starlink satellites currently orbiting and in operation are, but there are a lot. There are a few hundred. And it's by far the biggest. It continues to be, even increasingly so, by far the biggest, the most prolific satellite constellation in existence. And we're still in beta phase. So cross your fingers for that email from SpaceX saying that, congratulations, you're now eligible to receive Starlink service, because I will be signing up. And then on Friday, I'm sorry, I didn't show you the launch. This was a launch of the dork. This was the launch of the Starlink 9 mission here.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff.
M1D propulsion is nominal.
So, This was a long stream because of the orbit they had to get into to deploy the Black Sky Global satellites, and the Black Sky Global satellites were on top of the stack, so they had to be deployed first before the Starlink satellites. That's the nozzle. Oh yeah. Ooh, check this out. Look at this little glob of solid oxygen that drifts off and away from the rocket. So of course the Falcon 9 uses 9 Merlin engines. Well, the upper stage uses a single Merlin vacuum engine, but they have a drain valve that because the oxygen in the rocket continues to require venting even once they're in space, and that venting, once the oxygen comes in contact with the vacuum, due to the properties of matter and oxygen in a vacuum, it freezes solid. Not because it's cold, but because there's no pressure. And so what it does is it forms this fluffy sort of ball of solid oxygen at the tip of the drain valve. And it looks cool, and it sometimes floats around, and even though it's in close proximity to the burning red hot engine, it doesn't melt because there's no thermal conduction in space. There's not enough molecules to bump into each other for that. But it is one of those fluffy balls of solid oxygen that was mistaken by some very creative internet people as a mouse one time, and they said, despite the fact that we saw the rocket launch, we see things floating around in space, they see this fluffy piece of solid oxygen, which was explained by the announcer or by the commentator, and for some reason they think it's a mouse. Whatever. People are crazy. But in any case, okay, so let's see if I can find the deployment. It should be at the very end. Here we go. Starlink deployment. And so the way they do this, I saw a really cool Kerbal Space Program simulation of Starlink satellite deployment. And basically the way they do it is they spin, they put the Falcon's upper stage with the payload attached, with the Starlink satellites attached, into a head over tail spin, a slow spin, and then they just have like little springs that release the satellites, and because of the spinning motion, they get flung slowly away from the spinning rocket, just due to centrifugal force. It's really quite ingenious. It's a very simple mechanism. They don't require any fancy look at that, John Innsbrucker. They don't require any fancy connecting mechanisms in between the satellites. They just release them all at once, and they drift away naturally due to Newtonian physics. It's really quite ingenious. If you can get something done reliably and simply, there's no point in designing a complex system for it. And then, let's see, on Friday, Astra was supposed to launch their 3.1 rocket for the first time, again, but it got scrubbed due to excessive wind shear. Astra has been plagued by weather delays and other issues. This rocket was supposed to have launched on the 2nd, but a civilian boat wandered into the exclusion zone, and they couldn't get it out of the way before their launch window expired. And then on the 4th, 6th, and 7th, they scrubbed due to these weather delays. It turns out that the weather is sometimes questionable when you're launching from Kodiak Island, Alaska, which is right here. And I'm not actually sure why they chose that spot. I mean, it's great for polar orbits, of course, because, you know, it's not, I mean, you're not picking up much spin velocity. I mean, you're not picking up much velocity from the rotation of the Earth because it's so far from the equator, but it's fine for polar orbits, and I'm not sure why they picked a location that's in a really crummy weather zone. But maybe I'll do an interview with Astra one day, if they let me. All right. Let me take a look at the chat real quick. Only one unit. Now, some of these questions may have already been answered in the watching of these videos, but let me just address them here. Only one unit asks, didn't they launch 3 space vehicles on that mission? You showing the video that's referring to the SpaceX mission. They launched 2 Black Sky Global satellites and 57 Starlink satellites. So there were 2 deployments consisting of actually, I think the Black Sky Global satellites were deployed at the same time. If not, then there were 3 deployments. There was the 2 Black Sky Globals, and then the 57 Starlink satellites were all deployed at the same time. Katsu, hello from Finland. Hello from North Carolina, United States. Ian Pedlar says, I think the number is up to about 595 Starlink satellites. That sounds reasonable. Osama in Portuguese says that he loves launches and he follows them directly. That's good to hear. I'm sorry, I can't say that in Portuguese. Ian Pedler says that if I played the audio in the SpaceX stream, at some point they do say how many satellites total they had launched, but that I have no idea at what time during the broadcast they do that. The SpaceX broadcasts are not as tightly scripted as NASA broadcasts, where like at the end of a spacewalk they'll give you like a data sheet view with the summary of the number of hours and the number of spacewalks, etc., etc. They don't make it that easy. They kind of sprinkle their information throughout the stream. So Snow Kittens says that the Astra launch had to do with the DARPA challenge. So it was the Astra 3.0 rocket that was intended for use in the DARPA challenge earlier this year. That's the Defense Advanced Research Projects Agency, DARPA. They had a launch challenge, and Astra was the final competitor in that challenge. Unfortunately, their final launch opportunity they scrubbed, and they were unable to make the launch happen within the before the time limit expired for the challenge, and the challenge was not met by anyone. No one won the challenge. But then they lost that 3.0 rocket during a test of some sort. And so that's why this launch was going to be the 3.1 rocket. Okay, so looking ahead to this week, it is much more quiet than it was a couple of weeks ago. And so these things, space stuff tends to happen in clusters. Um, let me turn on the music. All right. So space stuff tends to happen in clusters. So you've got, 2 and 3 weeks ago was super busy because that was our Mars launch window, and you had the 3 missions that launched to Mars: the UAE from Japan, and then the Chinese mission, and then the Mars 2020. Additionally, you had, Doug and Bob returning from the space station. You had the Starship test this past week, and a lot going on. But now we're entering a quiet period where there's not many launches scheduled. So the only one we have this week is on Friday, August 14th at 5:33 p.m. Eastern, 9:33 p.m. GMT. Arianespace will launch an Ariane 5 ECA rocket with the Galaxy 30 communications satellite. Now this was scrubbed on, let me see, July 31st, and I think it may have been scrubbed again. But yeah, so this has been scrubbed a couple of times, but hopefully they get it up this time. Now, interestingly, in the previous Arianespace broadcast, the president of the company, Stefan Israel, as well as their primary commentator, lady I don't recall her name, they were located in a studio in France. Now, normally they would be at the launch center in Kourou, French Guiana, but due to COVID, they were located in France, and only the on-site personnel were in Guyana, French Guiana. So that spaceport actually has not seen a launch in more than 5 months now, since they shut down due to the pandemic. But hopefully on the 14th they get things moving. Now, somebody in a chat earlier mentioned that Rocket Lab was planning a launch sometime this week. Let me see. Nope, I am not seeing anything on the Rocket Lab Twitter. So keep your eye on the schedule. If a Rocket Lab launch pops up, then I will definitely be streaming it. And if not, then obviously I won't. Additionally, I wanted to mention, so I mentioned the Mars missions that launched. I wanted to give you a view of where Mars 2020 is right now. So currently, you see there right in the middle is the Earth, and Mars 2020 is very slowly arcing out in a wider orbit from where it departed the Earth a couple weeks ago. And it will take about 7 months for it to reach Mars. And so by that point, Mars will be much further along in its orbit. And so this view here is from the NASA EYES website. And I guess there's a website, and there's also an app that you can download, but it's NASA EYES, EYES. And what it lets you do is visualize the locations and information about all sorts of spacecraft. So if I refresh this page, because I had to zoom out to get this view, I had to zoom out a lot because we're looking at the solar system here. So if I zoom out a little further, oh, by the way, you see that little white arc sort of up and to the right of Earth is the current location of the Parker Solar Probe, which is pretty cool. And then in the background we actually have Hale-Bopp, which is, I guess it would be still headed out away from the sun in a weird direction. But that was the very big comet that we got that provided us with a show back in 1997. So if we scroll out here a little more, there's the sun. And so we've got stereo ahead and stereo behind, the two craft that are I I don't think they're actually at the Lagrange points. I think they're, maybe they are. I'll have to look it up. I don't like giving you wrong information, but in any case, they provide us with views of the sun from different angles so that we can, see more of it at the same time. All right. Anyway, so if I refresh this page, then it will give you a nice close-up view of the Perseverance, or rather the Mars 2020 craft with Perseverance rover inside. So if we rotate this, so that's what it looks like. Whoops. Oh, and it just went weird. Okay. Well, that was fun. While it lasted. But anyway, let me check the chat one more time, see if there's any pending questions. Atarukso says one of his launch schedules has Electron listed for the 12th. All right. Yeah, I heard that like it showed up on somebody's app or something. But I presume that if Rocket Lab doesn't announce the launch on their Twitter, then they're probably not going to broadcast it, which wouldn't make any sense because Rocket Lab always broadcasts their launches. So I'll just stay tuned to the scheduling websites and the Twitter verse, which is, Twitter's not my favorite platform, but it is where most organizations post the most up to the minute information on what they're up to. Mark Desire says James Webb not before 2021. No, James Webb is currently scheduled to launch on an Ariane 5 rocket in like October 2021, wasn't it? It was delayed somewhat from its like a couple of months or something. I think it was August to October or something like that. But yes, James Webb will be launching, darn it, next year, and it will be completely successful in its deployment and operation. James Webb will be magnificent, and nobody's going to tell me different. Snow Kitten says there's also an unconfirmed Long March 2D coming up. For what it's worth, we're not going to get a live view of it because it's China and they don't like us. But c'est la vie. Yeah, Maria Kutujan, Mars 2020 landing is in February. That's correct. February the 18th is when it will arrive, and we should have a live stream at that time in February. Mark your calendars. But it's not, so it may take them some time to get views back from the surface. The way it went with previous rovers is that we saw, because like the descent and landing happens, and then some minutes later we receive the data that it happened successfully because it's all automated. We can't be there for it. And by the time Perseverance reaches Mars, Mars will have proceeded further in its orbit. We will have proceeded further in our orbit, and it will be a few minutes of light lag time between the two planets. And so by the time we receive the information as to the success or failure of the landing, it's already happened. So what we will see is a live view of mission control at JPL, which is where the Mars missions are managed from, and this Mars mission is managed from, the rover missions, and we will see them cheering as they get confirmation that the entry, descent, and landing was successful. And then a short time later, they should receive some rudimentary images from the surface. But the data rates from deep space are slow because of just the limitations of I'm not actually sure what. So okay, so you can have high throughput but also high latency, like with for example, a geosynchronous satellite. It's 23,000 miles away, so there's lag. So you're not going to want to play your first-person shooter games on a geostationary satellite internet connection, but you can have high throughput. So anyway, I know there's also limitations in the deep space network of radio telescopes that are located, three installations located at 60-degree increments around the globe for receiving signals from deep space. And it's possible that some of the limitation in data throughput from deep space is because of those installations. It also may have to do with the transmission strength, because the and packet loss and error correction, etc., etc. Anyway, I'll have to do some research on it, because as an IT guy, it's a topic. Data transmission over interplanetary distances is a topic of interest for me. So I should do some research on it and then maybe make a video to convey what I have learned. But Ian Pedlar says 20-minute delay between here and Mars. That's up to a 20-minute delay. So at its minimum distance, Mars is about 30 million miles away. That's called when it's at opposition, when it's aligned with the Earth, like when it's close in its orbit to where the Earth is. But when it's on the opposite side of the sun, it is up to 20 minutes of light time away. The closest is about like 4 minutes, I think. So it'll be somewhere in between that. All right, so that about covers it for this edition of SpaceWeek Live. I appreciate your joining me on this little weekly journey, and oh yes, Perseverance landing is going to, Aturukso says, Perseverance landing is going to blow our minds with video cameras pointing up and down and microphones. I believe they do actually have a microphone that's going to be activated during the descent. So presumably we'll be able to, and there's a scientific reason for that. I think that they want to collect as much, I mean, if you're going to descend a craft through an alien atmosphere, you may as well collect some data while you're doing it. And I think that they're actually using the mics not just to sound cool, but to actually gather information on maybe the density or something regarding the Martian atmosphere. I'm not a planetary research scientist, so I'm not sure what all they're going to be analyzing, what all sort of data they're going to be collecting. But anyway, thank you all so much for coming, and do like and subscribe if you haven't already. Keep it raw, and I will catch you next week.